Ionic compounds are also known as salts, and one of the skills that you'll be expected to accomplish is determine the formula of an ionic compound or salt. And the way that you do that is you figure out the ratio of cation, or positively charged ion, to anion, or negatively charged anion, such that the overall charge is 0. And that's what your textbook calls the principle of charge neutralization. So let's look at the rules for writing the formula of ionic compounds. First, every single ionic compound has a positively charged ion or cation and a negatively charged ion or anion. That's because ionic compounds are held together by the attraction of the positive and the negative ion. So they have to have both. When you write the chemical formula, you never ever show the charges of the individual ions, even though you use the charges to determine the formula. When you write the formula, you do not include the charges. So for example, the formula for sodium nitrate is capital N lowercase a, capital N, capital O subscript 3. The charges are nowhere to be seen. But we also see that it's a 1-to-1 ratio. There's one sodium and there's one nitrate because sodium is +1 and nitrate is -1. Rule number 3, the cation is always written first. And generally, the cation is going to be a metal cation. Rule number 4, and this is what you're going to use to determine the overall formula for an ionic compound. Ionic compounds are electrically neutral. So what that means is the positive and the negative charge of the ions cancel one another out. And so you use that to determine the formula. So for example, let's look at the cation potassium, which has a +1 charge, and the anion carbonate, which has a -2 charge. When we write the formula, it's not going to be KCO3 because that would have an overall charge of -1. We've got to have 2 potassiums, which will have an overall charge of +2, to neutralize the -2 charge of the carbonate. So the formula for the ionic compound formed from potassium and carbonate is capital K subscript 2, capital C, capital O subscript 3. And then rule number 5, we use parentheses when 2 or more polyatomic ions are in a formula. That is the only time we use parentheses, when 2 or more polyatomic ions. So for example, we look at calcium hydroxide. Calcium has a charge of +2 and hydroxide has a charge of -1. So we need 2 hydroxides for each calcium for the overall charge to be 0. However, we just don't put a 2 after the H in hydroxide because that would say we have 1 calcium, 1 oxygen, and 2 hydrogen. And that's not the case. We don't have 2 hydrogen, we have 2 hydroxides. So whenever we have 2 or more polyatomic ions, we put the polyatomic ion in brackets and then the subscript below that. If we only have 1 polyatomic ion, we don't need parentheses. And if we have 2 or more simple ions, we don't need parentheses because it's very clear that the subscript of 2 refers to the potassium. It's only when we have 2 or more polyatomic ions that we use the parentheses.